Good afternoon. This is Kisop Kim, a second-year PhD student of KAIST, and we introduce a MulRan multimodal range dataset for urban place recognition. And this is a new dataset named MulRan, which has both radar and LiDAR dataset. This is a joint work with our lab members, Yongsang Park, Youngwon Cho, Jin-Yong Jung, and Ayong Kim. Our contributions are twofold. First, we release a new radar LiDAR dataset named MulRan. Second, we also propose a radar place recognition method. Why radar? Radar is getting academia's attention. First of all, we note that we'll talk about only frequency modulated continuous wave, or called FMCW radar in this paper. The necessity of the radar is already widely explained in the listed literatures. And in summary, many odometry methods have been developed, but radar's possibility and advantages are not restricted in the ego motion estimation. So we argue that we need a more radar dataset covers multiple environments so that the environmental diversity to be satisfied. Second, despite many odometry methods were developed, however, radar place recognition method is still not fully matured. But this place recognition method must be equipped to construct a radar SLAM. Our system includes two types of sensors, radar and LiDAR. Radar is from the Navtec, and ours have 6 cm and 0.9 degree of resolution per pixel. And the radar can see up to 200 meters. And our LiDAR is the Oster's OS164, having 64 rays. We also equip multiple navigation sensors such as RTK GPS, IMU, etc. Are not being released now, but used only to make 60 ground truth trajectory. In our dataset, we have total 12 sequences composed of 4 target sites and 3 sessions per each site. We note that we have a long circle-like sequence along the developing city called Sejong City. Compared to existing popular datasets such as KITI dataset, our sequences have multiple and multi-types of loops. So our dataset is adequate to evaluate a place recognition method enoughly. Also, our dataset has structural diversity, as you see. Particularly, a single Sejong sequence has many types of places, such as complex urban, rural-like, and less featured structures, for example, multiple bridges. From here, we introduce our second contribution, radar place recognition. Radar place recognition is must-have module to make a full radar SLAM system. We found our previous work, Scan Context, originally developed for LiDAR place recognition, also works well for radar data. We first downsized the original massive data into small size matrix with any interpolation. Also, a thing is different from the original paper. We proposed to use average rather than L0 norm to make a ring key from the descriptor. Then the overall pipeline is almost same as the original paper. For details of the method, please refer our previous ICRA paper. This is a place recognition result. Radar outperforms LiDARs and shows more consistent performance over multiple environments. We also conducted a long-term localization experiment. We localized a measurement from sequence 1 to the experience from the sequence 2. In this experiment, radar also outperformed LiDAR and showed high precisions at high recall. Now example time. Using the radar scan and accumulate them using the trajectory, the riverside map is constructed like this. Some example applications of our dataset is in the web. First of all, the second author of this MulRan paper also presents radar odometry method, and he evaluated using the MulRan dataset. Secondly, as we saw, MulRan dataset has a lot of loops, so adequate to construct an urban 3D map. So alongside the dataset, we also release a real-time LiDAR SLAM code and test it on MulRan dataset. Some useful links. And this work was supported by Naval Labs Company and National Research Foundation of Korea. And if you have any other questions, please mail me. Thank you.